All right, so let's take a look at this ED205, which is a very simple heap overflow. All right, so let me clear and go up and go into that directory. All right, and I've already brought down the source code here. You just download the source code and the executable code, which is why you need an Intel compatible processor here. And now you have this program. So let's take a look at the source code for starters. All right, and so what you've got here is you import some libraries, then you make a data structure which contains a name and another data structure that contains a pointer to a function. So data and FP. Then you have a winner function, which is going to print out a flag. And then you have a no winner function that says it's not been passed. So now you allocate the data structure and the pointer structure, and then you set the pointer to point to the no winner function. Then you take the argument that came in, the command line argument, and copy it into the name. And this, of course, is where there's an overflow. The name has only enough space for, I think, 64 letters, but you copy the command line argument, which could be longer than 64, into it, and so that name could overflow into the pointer, and now when you execute this, you can make this execute something other than no winner, and obviously you want to make it execute winner. So what you've got here is a sort of contrived situation where the heap will contain a pointer, like the return pointer. So the end result is it's going to be very much like exploiting a buffer overflow on the stack. So this is the simplest case of being in the heap. So if you run this program and give it something like hello, it will tell you where the data is and where the pointer is until a level has not been passed. So you can see the data is here at 1A0 and the pointer is at 1F0. So that's about 30, that's exactly B, C, D, E, F, 64 bytes further along. Anyway, that shows that a long enough string would override it. So we've seen the source code. All right, we know what's going on here. So now we can observe the heap. Let's put it in GDB, ED205. And then list, we can use source code debugging. It was compiled with the G flag, so we can use source code debugging to make our life easier. 31 to 34. This shows you, oh, let me get rid of the stupid colors. Set style, enabled, off. All right, and then run that again. All right, so now we can see this is where the string copy happens, which is where the overflow happens. So this is the interesting area. So if I run it, whoops, let me get back there. Okay, so if I run it, and give it data AAAA, then that's not going to do any overflow. That's a short enough entry that it'll fit in the reserved space, but I can examine the heap. You can see the heap. You can see the memory maps with info proc mappings. Oh, that's rude. Oh, I forgot to make a breakpoint. So I've got to put a breakpoint at line 33, which is going to be after the overflow, but before it uses this pointer. Okay, so let's put a breakpoint there, and now run AAA again. Now I can do info proc mapping because the program is running, and I'll just press space again to enter. Okay, so here you see the heap right here. So the heap is at that address, 804B1000, and there's other things here. These are libraries and such, but here's the heap being used. So I can examine it with X130X at that address, which is the same as it was when I did it before. That's handy, 804B1000. So I can copy it from here. Good enough. All right. So here's the heap, and I'm seeing one page of it. And I think I press enter to see more. Yep. And there we are. You see somewhere on the heap, here's the 41, 41, 41, 41. So that is the A's I put in. Then there's a bunch of gaps, and then down here is the pointer, 804F6. The code is typically 0804, and so this is probably the return pointer. Yep, which I said, the return pointer is down there looking like that. That looks very much like a pointer back to where the data detect section is, and I could tell, for example, if I disassemble no winner, I'll see that no winner starts at 80080484F6, and that's this number. So as I thought, that is the pointer that points to no winner, which is going to be used by the code to run something when I return. So clearly, I just need to make my data entry long enough to corrupt that value, and I'll gain control of the instruction pointer. All right, so now I can make a crash. I'm going to do that with Python. I could just type a whole lot of letters, but I'm going to want to be able to use non-printable letters. So let me use a Python code to do that. So I'm going to get out of the debugger and nano h1 and put in my Python code, which is just going to print 90 A's. I'm using this sys standout buffer right, so I'll be able to print non-printable characters later. But right now I'm just printing A's. So chmod plus x h1, and now if I run h1, there it are, it prints 90 A's. That's what I want. So I can now feed that into ed, and this is how you feed in the output of one function. This will run h1 inside the parentheses, and then take the output and treat it as a command line argument for ed205. And so now I'll get a segmentation fault. Instead of it printing no winner, so I've corrupted it. This is what I want. So some of that data corrupted it. And now I'm going to have to find out which characters ended up in there. So I'm going to copy h1 to h2 and nano h2. All right, and now I saw before that there was room for, I think, 64 characters in the code. In fact, let me take a quick look back at the source code. I think I've got it here. Yep, there was room for 64 characters in the name. So I think the first 64 characters are going to be handled correctly and are not going to lead to an overflow. So I can make this like that. I can just take 70. That's what I want to do. So let me go here. All right, so what I'm going to do is, instead of sending 90 A's, which caused a crash, I'm going to send 70. And then put in a non-repeating pattern so I can tell what's going on. So I'll use B, double letters. So that's 20 more. So now the total length is going to be 90. So it should cause a crash, but I should be able to tell which part of it caused the crash by seeing which numbers end up in there. So I'll save this. And then if I do an ls minus L, I'll see that my h2 is already executable because I copied it. So now, if I run it in the debugger, yep. Okay, and I run it with the input of $h2. And it crashes, and I can see the number here, 35, 35, 36, 36. That's the instruction pointer when it crashed, and you can tell that if you do info registers. You'll see EIP is in fact 5566. So 30 is 0, 31 is 1 in ASCII. So this is the 5566. So now I know what part of the string ended up in the instruction pointer. So let me get out of here. And let's copy h2 to h3. This is the process I usually do. I've been doing this a lot of time. And after I think I've found the instruction pointer, I always like to verify it. So it was the 5566 that ended up in the instruction pointer. So one way to do it, I can figure this is 0, 1, 2, 3, 4. This is 10 characters before that. So I can just change this to 80 A's before it. And then I'll put in something I can spot, like 1, 2, 3, 4 here. And in other cases, I've actually added extra stuff to the end to make the total length of the string the same. But in this case, I don't think that's necessary. So if I'm correct, the 1, 2, 3, 4 will end up in the instruction pointer. And this is something to check. So that's h3. So I go back in the debugger, and I run it with taking data from the output of h3. And, I'm missing a slash, ./h3. There we go. All right, and now it ends with 31, 32, 33, 34, which is 1, 2, 3, 4, which means I did correctly hit the instruction pointer. So now I can hit anything I want, and now I think I just disassemble winner. This is what I want. That's the address I want. So I'm just going to copy that and put it in my clipboard. And now I can easily work from this. I get out of here. I'll copy H3 to H4. By the way, notice that I don't keep modifying the same program over and over. I make copies because very often I make a mistake. And then I wish I could go back to the one or two steps back that worked. So I always keep everything that works and make another file. Then I can retrace my steps. So now I'm going to put in the contents of my clipboard. There, that's the address I want. So that's what goes in here. Instead of 1, 2, 3, 4 is that address backwards. And it's hard to read in these colors. Let me do this nano without colors. I know how to do this now. There we go. So the last byte is CB. Then it's 84. Then it's 0408. Okay, let's see if I go, oh, hit the 0 there. There, let's see if I got it right. CB 840408. Okay, that looks pretty good. So if I've done this right, this will win. So if I run ED204 and I take the input from H4, I should win. All right, maybe it's not ED, or it's ED205, that's why, all right. There, now level passed. All right, good. So that's what I wanted to show you. All right, and I think that's it for this one. Yeah, all right. And after you get that one working, then there are some extra credit ones where I'm actually using a remote server, and you can craft a string and send it up there, and the server will show you debugging. This is what you did before in ED202. So here, for example, I can put in hex stuff. So if I'm putting in hex, I guess to make AAA, I'd make 41, 41, 41, 41. So if I debug that, it will show me, it'll run a debugger on my server. It shows me some code, and it shows me the process proc map, and it shows me examining the heap here, which is, yep, that's there's the heap at 8,000. Not so sure this is as helpful as it should be. Anyway, then we'll see how people do on this one. I may need to modify this. One thing that troubles me is it doesn't seem to have the heap where it ought to have it. Anyway, I'll work on this one and see how I can do it. I haven't tried it in a while. The flags for the extra credit are not available in the Enter Flags window. Well, that's what I'm thinking. I'm thinking this is not showing you the heap anymore, which it should be. But you probably could do it. I see this has levels not been passed. Let me see. I bet I can make some progress in this one. What if I just put in a lot of these? And then debug. The output is level has not been passed. Okay. So there. No, it's okay. You can still do it. Here's the 4141. This thing is less useful than I thought. Wait, there they are. The 41s do show up here. All right. So anyway, I have, it only has ED205.1. The flags, are not available in the Enter Flags window. Oh, I see what you're saying. Okay, good. Thanks for telling me. Okay, I'll put those in. Okay, so this is doable, but I'll put them in the automated scoreboard. Good. Thanks for telling me. So it's ED205.2. FF add to, okay. Good. Okay, I'll do that right after this video is done. All right, let me stop this video.